Hello everyone, welcome back. At first glance, this instruction looks perfectly normal. LDR R3, equal to literal. But here's something interesting. It's not a real thumb instruction. In fact, the ARM7 processor never executes this instruction. So what actually gets executed? How does register R3 end up containing the address of literal? And what exactly is a literal pool? Let's find out. Let's begin with the following code. Our goal is simple. We want register R3 to contain the address of the label literal. Once R3 contains the address, the next instruction LDR R1, content of R3 can use it to load the actual data stored at literal. However, the instruction LDR R3, equal to literal is not understood by the processor. Instead, it is a pseudo instruction recognized by the assembler. Before the program is executed, the assembler automatically replaces it with a real thumb instruction LDR R3, content of PC, #2C. This is the actual thumb instruction executed by the ARM7 processor. Now let's understand how this instruction loads the address of literal. The generated instruction is located at address 2A. Like every thumb PC-relative LDR instruction, the processor performs same three steps. Step 1. Thumb-1 pipeline. Because of the Thumb-1 instruction pipeline, the program counter or the PC points 4 bytes ahead of the current instruction. That is, if current instruction address is 2A, PC is nothing but 2A plus 4, which is 2E. Next, we have PC alignment. For thumb PC-relative loads, the program counter or the PC is aligned to a 4-byte boundary. So if PC is supposed to be at 2E, then aligned PC will be 2C. Next, add the offset. Finally, the immediate offset is added. Aligned PC is 2C, offset is 2C, so effective address is 58 in hexadecimal. So the processor accesses memory location 0x58. Notice that the memory location 58 contains 3C. At first, this might seem confusing. Shouldn't it contain data that we have seen under the label literal? The answer is no. Memory location 58 belongs to a literal pool. A literal pool is a small block of memory automatically created by the assembler. It stores constants and addresses that cannot be encoded directly inside an instruction. In this example, the assembler has stored the address of the label literal inside the literal pool. So, at the memory location 58, you'll find the value 3C. When the processor executes LDR R3, content of PC, #2C that we just learned, simply loads the 32-bit value stored at the calculated memory location. So R3 becomes 3C. Notice something important. The processor doesn't know that 3C is an address. It simply loads the 32-bit value stored at memory location 58. It's the assembler that decides to place the address of literal into the literal pool. The next instruction is LDR R1, content of R3. This is a normal register indirect addressing instruction. The processor uses the address stored in R3, which is 3C. Therefore, it accesses the memory location pointed by register R3. Looking at our program, we know label literal is associated with this particular data. So after execution, R1 gets the value CAFE The first instruction loaded the address of literal and the second instruction used that address to load the actual data. That's all about this particular video. I'll see you in the next one.